Have you ever wondered how the concept of computing began? The cradle of computing isn't found in the Silicon Valleys of the modern world, but in the ancient civilizations of Mesopotamia. It all started with a simple device, the abacus, believed to have been invented around 2400 BC. This was the world's first known computing device. The abacus, with its rows of beads strung on wires set in a rectangular frame, was a tool for performing mathematical calculations. It was used for everything from simple addition and subtraction to more complex operations like multiplication and division. Imagine a device that could process numbers long before the invention of calculators and computers. The abacus was more than a tool. It was the birth of an idea, the idea that we could use devices to solve complex problems to make our lives easier. The abacus laid the foundation for the evolution of computing, but it was just the first step. Fast forward to the 19th century, and we see the emergence of the mechanical era in computing. It was a time of great ingenuity and innovation, a period when the seeds for modern computing were sown. The Victorian era was not just about steam engines and telegraphs. It also gave birth to the concept of mechanical computing. One of the significant inventions of this era was the analytical engine by Charles Babbage. This British polymath, often referred to as the father of the computer, conceived a device that was strikingly similar to a modern computer. The analytical engine was designed to be programmable and capable of performing any arithmetic operation, a true marvel of the 19th century. Babbage's machine was a mechanical behemoth, powered by steam and using brass gears to crunch numbers. It was the first general-purpose mechanical computer, a machine that held the promise of automating calculation. Despite the fact that it was never fully built during Babbage's lifetime, the analytical engine laid the groundwork for future computing innovations. Meanwhile, across the Atlantic, another innovator was making his mark. Herman Hollerith, an American inventor, developed the punch card system to revolutionize data processing. Hollerith's system was used to tabulate the 1890 U.S. Census, a task that would have taken years to complete manually. With the punch card system, the process was significantly expedited, demonstrating the immense potential of mechanical computing. Hollerith's punch cards became the standard for storing and retrieving information in computers until the mid-20th century. His invention not only revolutionized data processing, but also established the foundation for the development of modern digital computers. These mechanical devices marked a significant milestone in the evolution of computing. They represented the first steps towards automation and programmability, two key characteristics of modern computers. The mechanical era in computing was not just about brass gears and punch cards. It was a testament to human creativity and the relentless pursuit of innovation, a clear demonstration of how necessity is indeed the mother of invention. The 20th century brought a revolution in computing with the advent of the electronic era, an era that ushered in a new wave of technological marvels, forever changing the way we process and store information. This was the time when the first electronic computers were born, machines that would lay the groundwork for the digital world we live in today. Imagine a time when the most powerful computer was the size of a room, consuming massive amounts of power, and yet its capabilities were only a fraction of what we now hold in the palm of our hands. This was the ENIAC, or the Electronic Numerical Integrator and Computer. Completed in 1945, the ENIAC was primarily used during World War II to calculate artillery firing tables. It was a beast of a machine, weighing over 27,000 kilograms and covering an area of nearly 1,800 square feet. Fast forward to 1951, and we have the UNIVAC, or the Universal Automatic Computer. This machine was the first commercial computer produced in the United States, and its claim to fame was its use in the 1950 U.S. Census. It was also the first computer to handle both numeric and alphabetic data, a major leap forward in computing technology. But these gigantic machines were not without their flaws. They were prone to overheating and were incredibly expensive to produce and maintain. Enter the transistor, invented in 1947. These tiny devices replaced the bulky and unreliable vacuum tubes used in computers like the ENIAC and the UNIVAC. Transistors were smaller, faster, and cheaper, leading to computers becoming more accessible and affordable. The invention of the transistor marked a significant milestone in the evolution of computing. It paved the way for the development of integrated circuits and microprocessors, the building blocks of modern computers. This technological breakthrough ignited a wave of innovation, shrinking computers from room-sized behemoths to desktop-sized machines, and finally, to the portable devices we use today. With the electronic era, computing took a giant leap, paving the way for the personal computer revolution. This was a time when computing stepped out of the shadows of research labs and government agencies and into the homes and offices of everyday people. The 1970s and 80s marked the personal computer revolution. This was an era of unprecedented innovation and game-changing breakthroughs. The concept of computing was about to be transformed dramatically, shifting from bulky, expensive machines confined to labs and offices to compact, affordable devices that could sit on our desks at home. Enter Microsoft and Apple, two companies that would become synonymous with the personal computing era. They introduced user-friendly operating systems that made it possible for anyone, regardless of their technical know-how, to navigate the digital world. At the heart of this revolution was Microsoft's Windows and Apple's Macintosh, platforms that brought a graphical user interface to the masses, replacing command line prompts with icons and windows. This was not just about a change in technology, but a shift in perspective. Computers were no longer seen as mere tools for business and science, but as personal devices that could be used for a variety of tasks, from word processing and spreadsheet calculations to graphic design and gaming. Then came the emergence of the internet. What started as a military project in the 60s transformed into a global network connecting millions of computers. The internet opened up a world of possibilities: communication, information, entertainment, commerce, all at our fingertips. It was a game changer, further cementing the role of personal computers in our lives. The personal computer revolution was not just about hardware and software, but about people. It was about making technology accessible and user-friendly. It was about empowering individuals, giving them the ability to create, learn, communicate, and explore like never before. It democratized access to information and resources, breaking down barriers and opening up new opportunities. And while the personal computer revolution had its share of challenges, from concerns about privacy and security to the digital divide, it transformed the way we live, work, and play. It sparked a digital revolution that continues to evolve and shape our world. The personal computer revolution brought computing into our homes and hands, changing our lives forever. Today, we stand on the brink of a new computing revolution: quantum computing. Quantum computing is no ordinary evolution. It's a leap that could redefine the boundaries of what machines can do. But what exactly is it? At its core, computing is a new type of computation that leverages the principles of quantum mechanics. Unlike classical computers that use bits as their smallest units of information, quantum computers use quantum bits, or qubits. Here's the fascinating part. While a classical bit can represent a 0 or a 1, a qubit can represent a 0, a 1, or both at the same time, thanks to a principle called superposition. This allows quantum computers to process a vast number of possibilities all at once, potentially solving complex problems much faster than traditional computers. Another quantum phenomenon that quantum computers utilize is entanglement. When qubits become entangled, the state of one qubit becomes linked with the state of another, no matter how far apart they are. This means a change in one qubit can immediately affect its entangled partner, providing a super-fast way of transmitting information. Now let's talk about its potential. Quantum computing could revolutionize fields such as cryptography, material science, drug discovery, and even artificial intelligence. It has the potential to solve problems that would take classical computers millennia in mere seconds. But are we there yet? Not quite. Quantum computing is still in its infancy. Despite significant strides, practical, large-scale quantum computers are not yet a reality. Companies like IBM, Google, and Microsoft are heavily invested in this race, and breakthroughs are happening at an exciting pace. But as with any technological revolution, there are challenges. Maintaining stable qubits and reducing errors are some of the hurdles that scientists are striving to overcome. It's a tough nut to crack, but the rewards, they could be immeasurable. Quantum computing promises to redefine the future of computing, opening up endless possibilities. The journey of computing has been a remarkable one, from the abacus to quantum computers. We've traveled through time, witnessing how the dawn of computing started with simple counting tools. The mechanical era introduced us to intricate devices, weaving the fabric of automation. Then came the birth of the electronic age, a time that saw the transition from vacuum tubes to transistors, drastically reducing size and increasing efficiency. The personal computer revolution was a game changer, bringing computing power into our homes and offices, democratizing access to technology. We're now at the dawn of quantum computing, a frontier that promises to redefine our understanding of computation. Each era has been a step forward, a testament to human ingenuity and the relentless pursuit of knowledge. As we continue to push the boundaries of technology, one can only imagine what the future of computing holds.